Okay, so I was a little rushed at the end of the last video, as usual. So I'd like to start off this video again with a brief recap of how the last one concluded. So again, there was a typo here in the PowerPoint. I'll try to fix this. Remember to fix this afterwards. That said 12. It shouldn't be 12. It's 144. So if we take our 144 square inches, and we know that 1 inch is equal to 2.54 centimeters or 0.025 meters. We need to remember to square both of these. Square both that and that. Now squaring the 1 doesn't do anything, but squaring 0.0254 definitely does. So 144 times 0.0254 squared gives us our conversion factor. And again, the reason I point this out is because there are some homework questions that ask what is the conversion factor to convert between this particular unit and some other. And so what we're looking for is what is the number that we multiply by. So we're multiplying by 0.0254 squared. And then actually this is including both the conversion to inches to get from feet to inches, square feet to square inches, and then from square inches to square meters. So this is what we multiply our feet by. So the original problem was 376 square feet, and we want to multiply that by the conversion factor of 0.0929 square meters for every 1 square foot. So this is the conversion factor, which we multiply by to then get our actual answer, 34.9 square meters. All right, I've got one last example problem to conclude this chapter with. So again, it's converting derived units. This is an example problem I made up. I'm sure it's dating me. Most of you probably have no idea who Sammy Hagar is, but he had a song that he can't drive 55. And I just figured 55 miles per hour is a good starting point for a unit conversion problem. So if we wanted to convert that to meters per second and kilometers per hour, what would that be? So 1 mile is 5,280 feet. That's just something I kind of know off the top of my head. Maybe you don't have it memorized, and that's okay. You just need to know where to find this information. Inside cover of your textbook would be a good place to look. So 1 mile is 5,280 feet. Okay, so if I have feet here and I want to get rid of feet, I put it on the bottom of the next ratio. So the feet and the feet will cancel out. 1 foot is equal to how many inches? 1 foot is equal to 12 inches. Okay, but let's get rid of inches now. In the next ratio, I put inches on the bottom. So inches and inches will cancel out. 1 inch is equal to 2.54 centimeters. That is the definition of an inch. It's based on the metric system. It's based on 2.54 centimeters. So that's an exact conversion. Okay, but we don't deal with centimeters. We want to deal with meters. So again, we're going to have to get rid of centimeters by putting it on the bottom here so that the centimeters and centimeters will cancel out. And the relationship between meters and centimeters is that for every 1 meter, there are 100 centimeters. Like there are 100 cents in a dollar. Centimeter, cent. So finally, we've gotten to our desired unit here of meters. So we started with feet, put feet on the bottom, related that to inches, put inches on the bottom, related that to centimeters, centimeters on the bottom, and finally we've got to meters. So 1 mile is equivalent to 5,280 times 12 times 2.54, and then divide by 100. And all of these units cancel out, the feet and the feet, inches and inches, centimeters and centimeters, and what we're left with in the end is meters. So this is an equivalency that we calculated, that we derived. 1 mile is 1,609 meters. Okay, now if we specifically want to look at 55 miles per hour, we first want to convert the miles, and then we can convert the seconds, or the hours to seconds. So let's first convert the miles. So we've got 55 miles. Miles here is on top of our miles per hour ratio. So we want to put miles on the bottom here and convert that to meters. So how many meters is there in 1 mile? That's what we calculated in this first row. There are 1,609 meters in every 1 mile. So the mile on top here cancels out the mile on the bottom there, and we are multiplying by 1,609. So if we just multiplied by that, the miles would cancel out and we'd get meters per hour. But we want meters per second. So we now need to convert our hours. Okay, hours is on the bottom here, so we want to put it on the top over here, so that the hours on top cancels out the hours on the bottom. And 1 hour is 3,600 seconds, because there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600. So these hours are going to cancel out, and what we're going to be left with is meters per second, which is what we want. So we take 55 multiplied by 1609 divided by 3,600, and that gives us an answer here for part A of 25 meters per second. Okay, now let's say we want to convert that to kilometers per hour. Okay, so I take my 55 miles per hour. I'm going to get rid of the miles. Miles is on top here. Put it on the bottom over here. We want kilometers on top. Now, before we found that it's 1609 meters for every 1 mile, but if we convert this to kilometers, kilo is 1,000 or 10 to the third. So we want to move that decimal point 1, 2, 3, and we've got 1.609 kilometers, or times 10 to the third meters. 1.609 times 10 to the third meters. Okay, so that's what kilo is for. Kilo just takes the place of 10 to the third. It's just a shorter way, an easier way of saying that. So it's 1.609 kilometers for every mile. And that's all we need to convert here, because we're leaving the unit of time the same. It's still going to be hours. So all we need to do is convert the miles to kilometers. Take our 55 times 1.609, and we get 88 kilometers per hour. Okay, so that's the speed that Sammy Hagar cannot drive. He's got to drive more than 88 kilometers per hour. Okay, so that brings us to the end of chapter 1. This is a pretty introductory, pretty basic chapter, and we'll get into more physicsy kind of stuff in the next chapter.